Hello and welcome back again to data analysis in Python for the humanities. And what we're doing today, and we did last time, was to introduce NumPy and SciPy. And now we want to very briefly talk about normalizing numbers, which is another important thing you might want to do in data analysis. Normalizing numbers means to change them, a range of numbers, into another range that is always the same. And typically this is something either percentages or 0 to 1. 0 to 1 scaling is very common because we have all kinds of crazy measurements, right? You can measure the temperature, say, of a cup of coffee like this in degrees Celsius. You can measure it in degrees. You can measure it in degrees Fahrenheit. You can measure it, in whatever, in Kelvin. And now if you have different people measuring these temperatures in different ways and you want to compare them now, which is hotter and how do they cool down from being hot to being cold, and you have this series of numbers, but they're all expressed in different values, you would have trouble comparing them. And then it's the easiest thing is to normalize them, say we calculate them all, recalculate them to be in this range of between 0 and 1, and then we can easily see which is the higher temperature. We can compare them. How warm is the coffee after 5 minutes here and in the United States? And although the values originally are Fahrenheit and Celsius perhaps, then we always have them between 0 and 1. And why 0 and 1? Because it so happens that these are, if they are fractions of 1, then by multiplying it with whatever, we can easily transform that into yet another scale. So if I say I want them then in percent, I just multiply my 0.1 with 100 and then I have percent, right? Now, how do I normalize them? Normally you would think, okay, why is this even a thing? Why do I need to normalize? Why it's difficult to normalize them? It's not difficult, but it needs a little bit of thought. What you do is not just divide them by the bigger value. This is what you would think perhaps, but that's not it. What you have to do for the normalized value is for every value you subtract the minimum and then you divide by the range between maximum and minimum. And then you get your normalized value. And here you can see this. I would explain it in a moment why this is like this, but first let's have a look at it. So what I do here is to have some frequencies, right, which are here, and this is the frequency of the word death in 5 different texts, whatever it is, right? It doesn't matter, some frequencies. You have these raw frequencies, we'll print them, here they are, my raw frequencies, and again you see this is an array, it doesn't have commas. And after that we apply our formula. So I try to find the maximum and the minimum. I use these min and max functions that give you the maximum and minimum of an array. Again, very useful. I don't have to make a loop going through the array and trying to remember the maximum until now and so on, but instead I can just use min and max, which will do this very quickly. And now my normalized frequencies are all frequencies minus minimum divided by the range of maximum minus minimum. This is the formula we had above. And then I print my normalized frequencies. Here we go. These are my normalized frequencies. These are my raw frequencies. And here you see, if I plot them graphically, you see that they are exactly the same. Okay, so now why can I not just divide with the highest number? Why do I need to have this minimum in the example? The point is that you want to force every data point to fit exactly between 0 and 1. So you want your smallest number to be 0 and your biggest number to be 1. You don't want to just put your values into a range of 0 to 1. You want your smallest number to be 0. So the difference is, if I have these values here, we don't see it really because the third value is actually 0. But assuming you had many values that are all close to 1.0, right? And they're all around 0.9. Now, if I don't normalize it and I put them in the range between 0 and 1, all my values would be hanging somewhere on the top. And I wouldn't be using the range. What I want to do is, even if my smallest value is 0.9, I want this 0.9 to go to 0. and I want my highest, even if it's just 0.92, I want this to be 1. So I want to stretch my range to fill the area between 0 and 1. And this is what I'm doing. So the smallest number in my data set must become 0, and the largest number in my data set must become 1. And this is what I'm doing here. I am subtracting my minimum from every piece of data, which means that my smallest one will be 0. And then I divide by the range, and then I will get from 0 to 1. And you can see this in the lecture note. There's a calculation where it's demonstrated. But again, don't worry too much about the mathematics of it. Just remember the formula. And this is how you stretch it. Remember this piece of code. And don't worry about it. We are not doing mathematics. Okay, so the next thing and the last thing with that we will do here today is we will talk about a range. A range is a function that is like range, but you remember that range can only give you integer values between a value and another value. This is not always enough when we want to do calculations, data analysis. And with linspace, you say how many points you want to have between the extremes. So you say I want from 0 to 10 and I want to have 250 points. That's one way of getting a range. Sometimes this is not what you want. What you want is to say what division size you want between these two ends of the range, and not how many points. Because for you it's more important to have a particular division size than to have them equal. This is what you do with a range. You tell it the step size. Give me a point every 10 years between 1900 and 2000, right? This is one way of using this function. And here you see how this works. Again, I first have to import NumPy, and then I use a range, start and stop and step, right? And so this is how I get a step. Chapters are from 1 to 11 with a step of 1. If I omit the step, I get a step of 1. And if I print it, you see, here are my chapters. Now I go from 1 to 11 because, like with range, the end point is not reached, the end point is excluded, the starting point is included. So if I go from 1 to 11, I will get numbers from 1 to 10. Yeah, then I can plot them, I can do whatever analysis I want with them, and I can even do what I cannot do with range. I can even create fractions of whole numbers. So I can create a range from 2020 to 2022 in half years, in 0.5 years, and then I will get this 2020, 2020.5, 2021, 2021.5. Okay, so that was it. Thank you, and see you again in the next video, where we leave NumPy and we finally talk about SciPy, scientific functions.